Okay. Now we will start the first part of your unit 4, that is your free electron theory of metals. We'll start with free electron theory of metals. Okay. Okay. So this theory was used to explain various properties of metals like your properties of electrical properties, your thermal properties, or your magnetic properties. So this theory is used to explain the various properties, or it was able to explain the various properties. Various properties like your थर्मल प्रॉपर्टीज हैं आपकी मटेरियल की और इट हैव इलेक्ट्रिकल प्रॉपर्टीज और योर मैग्नेटिक प्रॉपर्टीज ऑफ सॉलिड and this theory is applicable to both metals and non-metals metals as well as non-metals but here we discuss only about metals. Okay, so there were two theories. First one was your classical theory or your Drude's theory, and second one was your Sommerfeld or your quantum theory. There were two theories proposed. First one is your named as classical theory because it obeys all the classical model, classical, or your Drude's theory of free electron. Okay. Second one was your Sommerfeld. Second one was your quantum or Sommerfeld theory or Sommerfeld theory. There may be question in your exam. Explain your Drude's theory or Lorentz Drude theory or classical theory. Okay. So for classical theory, we have for these all three names, we have a single theory that is your classical theory. Or it may ask explain Sommerfeld theory, or it can be asked explain the quantum theory. So you will explain the quantum theory. Okay. And if it is asked classical theory or explain Drude's model of free electron gas, or it may be asked explain Lorentz Drude model of free electron theory. So you will discuss about the classical theory. Okay. So there are different names for these theories. Okay. So first, what are classical and quantum? What are classical and quantum? Okay. अभी तक आप लोगों ने स्टडी किया है, आपके पास क्या है? इलेक्ट्रॉन. We have studied that electron behave as a particle, single particle, which is single. इसे आप डॉट से रिप्रेजेंट करते हो. ओके. इसको आप एज ए पॉइंट से रिप्रेजेंट कर सकते हो. ओके. दिस इज अकॉर्डिंग टू योर classical model, but according to your classic quantum but quantum mechanically we discuss that electron is your particle nature as well as your wave nature. It possesses both particle and wave nature. But in classical, we have discussed only your particle nature. That is your particle nature. We consider only your particle nature of electron. But in quantum mechanical, we discuss its particle as well as sense. Second difference is that when we calculate the velocity, in this case, we use Maxwell-Boltzmann statistics. Maxwell-Boltzmann statistics. Boltzmann statistics to calculate velocity. किस वेलोसिटी से आपके पास इलेक्ट्रॉन्स मूव कर रहे हैं किसी मटेरियल के अंदर, वो किसके अकॉर्डिंग आपके मैक्सवेल बोल्ट्जमैन स्टैटिस्टिक्स के. लेकिन क्वांटम मैकेनिक में क्या है, हम डिस्कस करते हैं Fermi Dirac statistics. Fermi Dirac statistics. Okay. थर्ड वन इज योर क्लासिकल में जो एनर्जी होती है दिस इज कॉन्टिन्यूस. क्लासिकल मॉडल में हम एनर्जी लेके चलते हैं, इट इज इन द कॉन्टिन्यूस फॉर्म. But in case of quantum mechanics, we have considered energy as quantized. Energy is your quantized. That is in the form of packets. Let here energy is your NH nu, where N is 1, 2, 3, 4. So energy in this case will be NH nu, sorry, H nu, 2H nu, 3H nu, 4H nu. मतलब पास क्या डिस्क्रीट वैल्यूज है एनर्जी की, जो आपके पास अगर डायग्राम बनाए इस केस में तो एनर्जी लेवल्स जो आपके डिस्क्रीट आएंगे. लेकिन इस केस में क्या आते हैं आपके पास, कॉन्टिन्यूस एनर्जी लेवल्स आते हैं. देयर फॉर्म्स अ बैंड. Okay, so these are the main difference which we'll be using. There are a lot of difference but we are using these differences only. Okay, आपके बेसिक्स के लिए इतना काफी. आगे हम क्वांटम वाला पार्ट करें तब उसमें डिस्कस करेंगे. ओके, तो हम डिस्कस कर रहे थे आपका फ्री इलेक्ट्रॉन थ्योरी. फर्स्ट मॉडल डिस्कस करते हैं हम, क्लासिकल मॉडल और यार क्लासिकल sorry Drude's model. First one we will discuss about the classical theory of free electron or your Drude's theory. This is after scientist Drude's who gave this theory in 1900. Okay, he used this theory to explain the electrical properties of metal. Electrical properties. He used this theory to explain the electrical properties. Okay, so he considered that, according to his theory, he considered that the electrons, कोई भी आपके पास मेटल है, वी हैव अ मेटल. मेटल में क्या होता है आपके पास, न्यूक्लियस है. फर्दर शेल्स में आपके पास क्या है, इलेक्ट्रॉन्स होते हैं. वी हैव इलेक्ट्रॉन्स इन द फर्दर शेल. ओके, जो आउटर मोस्ट इलेक्ट्रॉन्स है आपके पास, आउटर मोस्ट आर योर वैलेंस इलेक्ट्रॉन्स. These are the valence electrons. So according to this theory, his theory, he considered that each metal have large number of free electrons. आपके पास मेटल में क्या होंगे, बहुत सारे एटम्स होंगे. मेटल के अंदर क्या एटम्स है आपके पास, these are the nucleus of atoms. हर एक एटम के अपने अपने वैलेंस इलेक्ट्रॉन्स हैं. ठीक है, so we have large number of free electrons. So he considered that in metal we have large number of free electrons. Large number of free electron या वैलेंस इलेक्ट्रॉन्स. ओके, तो उसने क्या कंसिडर किया कि दीज फ्री इलेक्ट्रॉन को उसने कंसिडर किया, दे आर बिहेविंग एज molecules in a perfect gas. They are behaving as molecules in perfect gas. गैसियस स्टेट में हमारे पास क्या होते हैं, मॉलिक्यूल्स क्या होते हैं, फ्री होते हैं. गैसियस स्टेट में हमारे पास क्या होते हैं, मॉलिक्यूल्स क्या होते हैं, फ्री होते हैं, और दे आर free to move and in any random direction. So he considered that these electrons are as molecules in a perfect gas in a conductor. Perfect gas. Okay. So this theory was also named as free electron gas theory. because he considered the electron as the molecule in a gas. Okay, so he considered this theory. So this theory is also named as your free electron gas theory. Okay. Electrons are behaving as molecules in perfect gas. Okay, so there are assumptions of this theory. First assumption is that your first this one, that electrons are behaving as a molecule in a perfect gas. Okay. Second is that these electrons, first one is your this. Second one is that these electron move randomly in any direction. मॉलिक्यूल्स एज अ मॉलिक्यूल बिहेव कर रहे हैं तो उसकी प्रॉपर्टीज भी फॉलो करेंगे. एज अ मॉलिक्यूल बिहेव कर रहे हैं ना परफेक्ट गैस तो उसकी प्रॉपर्टीज भी क्या करेंगे, फॉलो करेंगे. मॉलिक्यूल्स क्या करते हैं आपके रैंडमली मूव करे तो इलेक्ट्रॉन्स वी एज्यूम दैट दीज फ्री इलेक्ट्रॉन इन एनी डायरेक्शन या ऑल पॉसिबल डायरेक्शन इन एनी डायरेक्शन. कि हमारे पास किसी भी मेटल के अंदर तो वो कहाँ मूव कर रहे हैं, किसी भी डायरेक्शन में वो रैंडमली मूव कर रहे हैं. ओके. थर्ड वन इज योर क्लासिकल मॉडल है तो हमारे पास क्या स्टैटिस्टिक्स फॉलो किया था, एमबी यानी मैक्सवेल बोल्ट्जमैन स्टैटिस्टिक्स. सो देयर वेलोसिटी विल बी in accordance to this, velocity will be in accordance to your Maxwell Boltzmann statistics to MB statistics. Okay. Fourth one is your average kinetic energy. The average kinetic energy, that is K dot E, is 3 by 2 kT of single electron. ये जो एनर्जी निकाली हमने 3/2, ये भी हमने मैक्सवेल बोल्ट्जमैन स्टैटिस्टिक्स यूज करके वहां से निकाल ली. ठीक है, यहाँ पे हम डायरेक्ट यूज करेंगे. दैट इज योर एवरेज काइनेटिक एनर्जी इज योर 3/2 kBT of a single electron, where kBT is your kb is your Boltzmann constant, T is your temperature. ठीक है, रैंडम मोशन है हमारे पास तो ओवरऑल करंट कितना आ जाएगा इस केस में, वी हैव ओवरऑल करंट इज इक्वल टू 0. We have I is equal to 0 in this case. So fifth is your, that is, in absence of electric field, in absence of electric field, motion is random. मोशन आपका क्या है, रैंडम मोशन है. सो नेट करंट विल बी 0 बिकॉज करंट इज योर मोशन ऑफ इलेक्ट्रॉन्स. करंट इज योर मोशन ऑफ इलेक्ट्रॉन. तो हर एक इलेक्ट्रॉन में जो करंट आ रहा है आपके पास वो कैंसिल आउट हो जाएगा दूसरे इलेक्ट्रॉन. अगर इलेक्ट्रॉन इस मोशन में है, दूसरे वाला इसके अपोजिट है, तो नेट करंट इस केस में कितना आ जाएगा आपके पास, 0 आ जाएगा. ओके. सिक्स्थ वन इज योर, जैसे हमने इलेक्ट्रिक फील्ड अप्लाई करी, इन प्रेजेंस ऑफ इलेक्ट्रिक फील्ड, these electrons will gain some velocity. These electrons will gain some velocity known as your drift velocity. ये हमने सेमीकंडक्टिव मटेरियल्स में भी स्टडी किया था। ड्रिफ्ट करंट जब हमने स्टडी किया, जैसे हमने इलेक्ट्रिक फील्ड अप्लाई करी तो इलेक्ट्रॉन्स क्या करेंगे, अपना रैंडम मोशन छोड़ के वो टुवार्ड्स द पॉजिटिव साइड ऑफ बैटरी की तरफ अट्रैक्ट हो जाएंगे, और जिस वेलोसिटी से वो मूव कर रहे हैं दैट इज नोन एज योर ड्रिफ्ट वेलोसिटी। ओके, इन डायरेक्शन, दिस इज इन द डायरेक्शन opposite to applied electric field, opposite to applied electric field. Okay, next is your इलेक्ट्रॉन रैंडमली मूव कर रहे तो इनके साथ कोलिजन भी होगा। इलेक्ट्रॉन आपके पास रैंडमली मूव कर रहे हैं, सो वी विल बी हैविंग सम कोलिजन्स बिटवीन टू इलेक्ट्रॉन्स। इलेक्ट्रॉन आपके पास रैंडमली मूव कर रहे हैं, एक इधर से आ रहा है, तो देयर विल बी कोलिजन। कोलिजन के बाद इनकी डायरेक्शन क्या हो जाती है, चेंज। जैसे मान लो आपके पास ये मूव कर रहे हैं अपोजिट डायरेक्शंस में आफ्टर कोलिजन, तो एक कोलिजन के बाद सेकेंड कोलिजन के बीच में जितना टाइम है दिस इज नोन एज योर रिलैक्सेशन टाइम, दिस इज नोन एज योर रिलैक्सेशन टाइम, represented as tau. So relaxation time is defined as the time between two successive collisions. It is a time between two successive collisions. Okay. एट्थ है आपका, इलेक्ट्रॉन्स के हैं आपके पास, फ्री इलेक्ट्रॉन्स हैं, दीज आर फ्री इलेक्ट्रॉन्स, लेकिन ये क्या है आपके पास, दीज आर बाउंडेड बाय electrostatic force of attraction, electrostatic force of attraction. So these electrons क्या करेंगे, they cannot leave the metal, they cannot leave the metal। किसके बीच में इलेक्ट्रोस्टैटिक फोर्स ऑफ अट्रैक्शन है आपके पास, जो न्यूक्लियस है और इलेक्ट्रॉन के बीच में इलेक्ट्रोस्टैटिक फोर्स ऑफ अट्रैक्शन है। तो जैसे हमने अज्यूम किया कि इलेक्ट्रॉन्स क्या है आपके, they cannot leave the boundaries of metal। Okay, so these are the assumptions of your classical theory. First one is your that electrons are behaving as your molecules in a perfect gas. Second, perfect gas में molecules behave कर रहे तो हमारे पास क्या है, random motion होगा in any possible direction. Third one is your that is they obey the Maxwell-Boltzmann statistics. So in order to calculate the energy as well as velocity, we follow the MB statistics. Okay, and the average kinetic energy of a single electron is your 3 by 2 kBt. For n electron it will be 3n by 2 kBt. Okay, next one is your when the field applied field is zero, net current is your zero, because total number of collisions will be in one direction will be, sorry, total number of electron in one direction will be equal to the total number of electron in the opposite direction, so net current will be zero. Next assumption was that when we apply electric field there will be some drift in electrons will drift towards the positive terminal of the battery. And seventh one is your that there is a relaxation time between two successive collision named as your tau, that is your relaxation time. Eighth one, eighth postulate is that that these electrons are free but they cannot leave the boundary of metal because they are bounded to the positive nucleus by some electrostatic force of attraction. Okay, so these were the assumptions of your classical theory, and these assumptions led to sorry led to explanation of some phenomena like, which we name that the success of this theory is that it was able to explain various properties like your first one. This classical theory was able to explain the Ohm's law. Was able to explain the Ohm's law. Second, it was able to explain the high electrical and thermal conductivity. Conductivity of metal. It can also explain the optical properties. Fourth one, it also explains the high luster and opacity of metals या फिर opaque nature of your metals. So these are the success of your classical theory, that is it was able to explain the Ohm's law. Second one was is that it was able to explain the high electrical as well as high thermal conductivity of metals. इलेक्ट्रिकल कंडक्टिविटी है और थर्मल कंडक्टिविटी है वो हाई क्यों है, इस नेचर को एक्सप्लेन किया इस थ्योरी ने. सेकंड वन इज योर ऑप्टिकल प्रॉपर्टीज, दैट इज योर इट कैन एबल टू एक्सप्लेन दी बैंड गैप. इसके अंदर क्या होता है, मेटल्स के अंदर बैंड गैप क्या होता है आपके पास, होता ही नहीं, क्योंकि हमारे पास क्या होता है मेटल्स में ओवरलैप होता है. कंडक्शन बैंड वैलेंस बैंड क्या करते हैं, ओवरलैप करते हैं. इट कैन आल्सो एक्सप्लेन दिस प्रॉपर्टी. फोर्थ वन इज योर इट एबल टू एक्सप्लेन द हाई लस्टर एंड ओपेक नेचर ऑफ मेटल्स. मेटल्स के अंदर जो लस्टर होता है, जो शाइन होती है, इसको भी एक्सप्लेन कर पाया था. और ओपेक, दैट इज योर दीज मेटल्स आर ओपेक टू लाइट. So these properties can be explained using this classical theory. Okay. However, there are some failure of this theory. It can explain these four phenomena, but there are some phenomena or properties which cannot be explained using this theory. So, fail this theory. First one was that it could not explain the temperature dependence of resistivity. Temperature dependence of resistivity, that is your rho. It can explain the Ohm's law. Ohm's law ने explain किया आपके पास जब हमारे पास टेम्परेचर जीता, लेकिन जैसे हमने टेम्परेचर रेज किया तो चेंज आ रेजिस्टिविटी में. इट कुड नॉट एक्सप्लेन दिस phenomena. Okay. Second one was that it could not explain the behavior of heat capacity and susceptibility of conduction electrons. That is your heat capacity and susceptibility of electrons. Okay. Also, magnetic behavior like your ferromagnetism. कि कोई मटेरियल फेरोमैग्नेटिक नेचर क्यों शो कर रहा है, इट कुड नॉट एक्सप्लेन दिस ferromagnetism nature of material. Okay. Various phenomena like your photoelectric effect, Compton effect, and black body radiation are cannot be explained using the classical theory, because in this photoelectric Compton black body radiation, the energy is quantized. In these, energy is considered as quantized. But in case of classical, we have considered energy to be a continuous form. So these phenomena was not explained by the classical theory of free electron. That is your temperature dependence of resistivity. Second one is your behavior of heat capacity and susceptibility of electrons. Fourth one, ferromagnetism nature of material. And the last one is your photoelectric effect, Compton effect, and black body radiation. These phenomena cannot be explained by the classical theory. Okay. So one more theory was given in the year 1909 by Sommerfeld, which is named as quantum theory because it is based on the quantum model of electron. Because it was based on the quantum model of electron, that is electron can behave as particle as well as a wave. Okay. Okay. So this was the theoretical part of your classical theory. Let's see some numerical part. So we discuss the electrical conductivity. We are discussing the electrical conductivity, na? So we find out the electrical conductivity in case of classical model. Find out the electrical conductivity. That is your sigma. Okay. So we have considered the electron as molecules, and these are obeying the Maxwell-Boltzmann statistics. Okay. So according to Maxwell-Boltzmann statistics and kinetic theory of gases, because we are considering as electron gas, electron gas. So according to kinetic theory of gases, their velocity will be kinetic theory of gases. Velocity of electron, velocity of electron will be under root of 3 kbt by m. Initially, we have considered the electrons are moving randomly. Initially, we are considering that electrons are moving randomly, and the random velocity is this under root of 3 kbt by m. Okay, here kbt is your Boltzmann constant, T is temperature in Kelvin, m is the mass of electron. Okay, when we apply an electric field, that is E, when we apply an electric field, that is your E, these electron will drift towards the positive terminal of battery. These electron will drift towards the positive terminal of battery. So, with the application of electric field, these electron will experience a force, which is F. It is equal to minus में E, because we know that F is equal to QE. Okay, here Q is your charge on electron, that is your E. A negative sign shows the opposite direction. Okay, also we know that F is equal to ma according to Newton's second law. So equating these two, we can find out the value of acceleration. That is, acceleration will be minus E into electric field over m. Okay, so the acceleration faced by the electron after application of electric field, it will be minus E into electric field by the mass of electron. Okay, negative sign, negative sign shows that movement of electron is in opposite direction to applied field. Movement of electron is in opposite direction to applied electric field. Okay. As electrons are moving, there will be collision between electrons. as electrons are moving, there will be collision between electrons. So the time between two successive collision is termed as your relaxation time. That is tau. We have given in the assumption that the relaxation time is the time between two successive collision of electrons. Okay, so time will be, it will be tau is equal to distance travel, let it be lambda, over velocity. Time is defined as your distance over velocity. Let's assume that distance traveled is your lambda. Distance traveled is your lambda. Okay, velocity is your v. We have already find out v is your lambda over under root of 3 kbt over m. Okay, or you can write lambda into under root of m over 3 kbt. Okay, this is your expression for your relaxation time. So during your relaxation time, there is no collision. During the relaxation time, there is no collision. There is no collision. So due to application of electric field, electron will experience a drift velocity. During relaxation time आपके पास क्या है? There is no collision occurring. So electron will experience a drift velocity due to applied electric field. Due to applied electric field. So we can write that velocity, that is drift velocity, it is equal to acceleration into your relaxation time. Into relaxation time. And we have find out relaxation time and acceleration. So putting these values, we can find out the expression for your drift velocity. That is your E over m into tau. And tau have values is equal to lambda under root of m over 3 kpt. Okay, so this is the drift velocity with which electrons are moving upon the application of electric field. Okay, this is the drift velocity with which electrons are moving. Okay, or we can simplify write as at minus में e lambda under root of 3 m kbt. Okay, we can write this as it. Okay, this is for one electron. This was for one electron. Okay, but in the sample we have n number of electrons. We have n number of electrons. Total drift velocity will be n times. Total velocity will be n times. Okay. So we define a quantity that is your current density, which we have already discussed in the semiconductors. That is your current density, which is defined as the charge flowing per unit area per unit time. Per unit area per unit time. That is, it will be minus में n e v d. यहाँ पे n इंट्रोड्यूस कराते हैं. Will minus n times charge into velocity of single electron. So total current density will be minus n e square e lambda over under root of 3m kbt. Okay, so this is the total current density. This is because of drift of electrons, so JD. So JD is find out to be minus में n e square into electric field into lambda, that is your mean path between two collisions, your distance traveled, divided by under root of 3m kbt. Okay, or we define as conductivity. It is equal to the ratio of current density and electric field. It is the ratio of current density and electric field. So sigma was found to be ne square lambda over under root of 3m kbt. Okay, here it is positive because one negative is here and one negative is here. So we have current density is equal to plus ne square e lambda under root of 3m kbt. So we find the electrical conductivity using the classical model of free electron gas. Okay, this is the conductivity. This is your conductivity. Or this is also named as your Roots formula for conductivity. This is also named as your Roots formula for electrical conductivity, because we are talking about the electrical properties, not thermal. Okay, root formula for electrical conductivity. Okay, so this was all about the classical theory or classic roots theory or free electron gas theory of metals. Okay, next in the next class we will discuss about the quantum theory.